Alright, so today we're going to be completing the square primarily, and then at the very end we'll talk a little bit about the discriminant, but mainly it's about completing the square. So there are two basic forms of a quadratic. The standard form is y equals ax squared plus bx plus c. So this standard form is primarily used when we are finding solutions. And you can find solutions by graphing, by factoring, or by the quadratic formula. Alright, the vertex form of an equation. This is the one that we use to graph it. So we've been working with this one past couple of days. Is a open x minus h squared plus k. And this is the one we use to graph. Because when we have this form, we know how we've stretched, moved right or left, moved up or down. So what we're doing today is we are completing the square, and the purpose of that is to go from the standard form to the vertex form. So if I give you an equation in the standard form and you want to go to the vertex form, you're going to use this method called completing the square. Alright, so that's what that sentence right here says. When the equation of a quadratic is written in standard form, it is necessary to complete the square to find the coordinates of the vertex of the graph. So if we look at example 1, we have y equals 3x squared minus 12x plus 36. So this is currently in standard form. So if I asked you to graph this right now, you wouldn't really know how to graph it. We need to get it into vertex form to be able to tell how to graph. So I'm going to write the steps and then I'll do a step. So step 1 is factor out the a from the x squared term There's actually 3 parts to step 1. So the next part is to separate C. And then the last part is to put in blanks. Okay, so step 1, y equals. So the a is this number 3 right here. It's the number that's in front of the squared term. So you want to take that out of the set of parentheses and then factor it out from the x squared and x term. So that's these two right here. So that's x squared, and then 3 would multiply what to get you negative 12x? So that's minus 4x. Okay? And then we're also going to separate the number 36, that's the C value, and we're going to put in blanks. So putting in the blanks is plus blank, and then you close it, plus 36, and then plus another blank. So this is your step 1. It's kind of just setting it up to do the rest of your steps, because we need to know what we're going to fill in, these blanks, and that's going to be according to this portion of our quadratic. All right, our step 2 is going to be half of the middle term and squared, and then also compensate. So I'm going to explain more about why these things work. For now, if you'll just do this with me, It's one of those things I have to show first and then talk about second. So half of the middle term squared and compensate. So I'll do this step in red. So half of the middle term. Well, I'm looking at this blank right here. So this blank is going to be half of the middle term, which is -4. So I'm going to take half of -4 and I'm going to square that. So that's what goes right here. And again, that -4 came from right here, and the rule is always to do half of that middle term squared. So half of -4 is -2. -2 squared is +4. Now, in order to compensate, since we're working on one side of the equal sign, compensating is like if somebody lets you borrow money, you have to pay them back. So if they give you $4, then you're going to take away $4 from your bank later. It's an add and a subtract compensation. So what I mean by that is this 4, we just kind of added to the equation. Actually, and not only is this 4, but this 4 is inside of the parentheses, so it's going to multiply with this 3. And 3 times 4 make +12. So I've added 12 to my right side of the equation. In order to compensate, still working on that same right side of the equation, I need to subtract 12. So since this was a +12, this is a -12. So if this had been negative, then this would have been positive. Compensation is opposite and equal. All right. And we're actually almost done. Step 3 is just finishing it off. So step 3 is y equals a x minus h squared plus k. So if you notice, this is the vertex form. This is exactly what we were trying to get. And that h is going to come from, once again, half of the middle term. So, step 3, let's do this in green. So I get y equals, this 3 is still there, open, and then it's x, and then this h, how am I going to get this h? So it's half of the middle term, which is this step right here, half of -4. So half of -4 is -2. And then squared, 36 minus 12, +36 minus 12 makes +24. Okay, so this is our answer. Let me talk a little bit why this is exactly what it is. If you took, you don't have to do this that I'm about to do, I just want to show you why this works. If you took x minus 2 and squared it, we know that we'd actually have to FOIL all that. So if I took x minus 2 times x minus 2, I'd get x squared minus 2x minus 2x plus 4, and that actually is minus 4x. So x squared minus 4x plus 4. It is on purpose that this is the exact same thing that you see here. That is not a coincidence. That should absolutely happen. Because basically what you've done is instead of writing all of this x squared minus 4x plus 4, you've wrote it as x minus 2 squared. Okay? And then if you also multiplied times the 3 and then added the 24, you'd actually go back up to the very beginning. Okay, so what we've done is we've taken this standard form and written it in vertex form. It's not about changing the equation, it's just about changing the way you write the equation so that now we can graph it, because I know how to graph this. I know that this means I've gone right 2 and up 24, and I've vertically stretched it. So right 2, up 24, that's my new vertex. And it's still positive, so it's still going to be an upward U. It's just a little bit skinnier than maybe it used to be. Okay, so now I know how to graph it because it's in that nice pretty vertex form. All right, let's do the next one. So in the next one, same steps. First, you're going to take out the negative half. So that's that number right here. So negative half, open. So that's going to be x squared. Now, before you just go filling in the numbers, remember that you got to multiply to 5x, and that is a positive 5x. So a negative times another negative is going to make positive, and then you got to say half times what is 5. So half times 10 is what gets you 5. 10x gets you 5x. So before you go on, if you just want to check that, kind of do in your head, okay, negative half times x squared is negative half x squared. Negative half times negative 10 is positive 5x. So that's just a quick checking to make sure that you've done that step right. Okay, don't forget your blinks. Minus 7 plus blank. All right, so this is half of negative 10 squared. So half of negative 10 is negative 5, squared is 25. Now, our compensation blank is going to be half times 25. I'm sorry, and it's negative half times 25, which is negative 12.5. So to compensate negative 12.5, I need to add positive 12.5. Okay, and now we're really basically done. We're just ready to write the equation. So y equals negative half x, half of negative 10 is minus 5 squared, and that makes negative 7 plus 12.5 is 5.5. Okay? All right, so if you need to pause it to kind of go through exactly how I got all that, again, you can. I'm going to go ahead and continue and graph this. So graphing, I know that this would tell me to reflect it, so now it's going to be a downward shape U. This tells me to compress it, which makes it wider. This tells me to go right 5 and up 5.5. So if you want to write that down, that negative sign right there makes me reflect. The half right here makes me vertically compress. This tells me to go right 5, and this tells me to go up 5.5. So here's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then it's going to go down, and it's going to be a little bit wider. And that's it. All right, so on B, I want y'all to go ahead and try and do this. Before you push pause, though, you might want to rewrite this as y equals negative 2x squared. That x squared term is supposed to come first. So why don't you go ahead and pause it, and then I'll go through this. All right, so we take out the negative 2. So that's x squared positive 6x plus blank minus 13 plus blank. So half of 6 is 3. 3 squared is 9. But that makes negative 18. So to compensate, I'll add positive 18. So now I've got negative 2 x plus 3 squared plus 5. So to graph it, reflect, stretch, left 3, up 5. So left 3, up 5, reflect, and stretch. There we go. All right, last part is the discriminant. So the discriminant of a quadratic is what tells you how many solutions you're going to have. So it tells you how many solutions your quadratic has. And the discriminant actually comes from the quadratic formula, so I'm just going to write that down. You don't really have to know this all the way, but we are going to talk about why it is the way it is later on, so I'm just trying to kind of introduce it today. So negative b plus or minus square root b squared minus 4ac all over 2a. Now what the discriminant is it's only the radicand, which is the part under the radical. So it's the b squared minus 4ac. That's what the discriminant is. So you're going to plug in your a, b, and c and do the discriminant. So the formula for the discriminant is if b squared minus 4ac is a number larger than 0, then it's going to have two real solutions. If b squared minus 4ac is equal to 0, then it has one double real solution. And if b squared minus 4ac is less than 0, then it has two imaginary solutions. Okay, so let's just do one example. So for now, I don't really expect you to understand exactly why these are the way it is. I just want you to figure out the inequality and then write the answer. It's either two real solutions, one double real solution, or two imaginary solutions. So ax squared plus bx plus c. If you want to rewrite this, you can go ahead and do that. It's negative 2x squared plus 3x plus 1. So my a is negative 2. My b is 3, and my c is 1. So when I plug in b squared minus 4ac, I get 3, because that's my b, squared minus 4 times negative 2 times 1. So this is just algebra from here. 3 squared is 9, minus 4 times negative 2 is negative 8, times 1 is still negative 8, which really makes 9 plus 8, and you could say that that's 17. That's really not the point. The point is that that's going to be a number larger than 0. So therefore the answer to this is that this would have two real solutions. Okay, and that's it. You're not actually saying what they are. You're just saying two real, one double real, or two imaginary.